supermassive black hole sitting at the center of every big galaxy? What if what we're seeing is a trick of distance and density, an optical illusion made by a whole lot of stuff packed into a tiny-looking spot? Here's the idea. When you've got tons of gas, dust, and stars crammed into the core of a galaxy, their combined gravity creates a center of mass. Just like two stars orbit a point between them, that whole crowded region orbits a shared center. From far away, that center might look like a single powerful object, when it's really the average of many. So let me show you what convinces most astronomers of supermassive black holes, and then question it. First, the Milky Way. At the heart of our galaxy, stars whip around an invisible point we call Sagittarius A. We've tracked their orbits for decades. Some move so fast, thousands of kilometers per second, that the math says there's about 4 million suns worth of mass inside a space smaller than our solar system. That's tiny for that much mass. A cluster of normal stars that dense would be blazingly bright, smash itself apart, and collapse. Second, we've imaged a ring around darkness in M87 and in our own galaxy, the famous black hole photos. That glow matches what we expect from hot gas skimming a point of no return, bending light into a bright ring. Third, quasars. They're galaxies with cores so energetic they outshine trillions of stars. The best explanation has been matter falling into a supermassive gravity well, releasing extreme energy on the way in. Now, the question. Could a dense, tangled center of mass, gas, dust, stellar remnants mimic all of this? From far away, light blurs, motion blurs, and we reduce the chaos to a single point. If enough material orbits a common center, the gravitational math still works. Maybe we're mistaking the group for a black hole person. What would that need to be true? The mass would have to fit in a very small region without shining too brightly or flying apart. The motions of stars would need to match a smooth, invisible central pull, not a messy swarm. The light bending, the ring-like glow, would have to come from curved paths through a dense medium, not space-time itself. So here's how I test the illusion idea. Track more individual stars closer in. If their orbits precess exactly as predicted by a single compact mass, that argues for a black hole. Look for flickers. A swarm has many clocks. A black hole accretion flow has characteristic timescales tied to one event horizon. Measure polarization and lensing patterns. Space-time curvature leaves a specific signature that a gas fog can't fake. I love the instinct to question the default story. A center of mass is real physics. The challenge is scale. To match observations, that center has to be insanely compact and dark. So compact and so dark that by our current definitions, it behaves like a black hole. But science moves by poking holes. Pun intended. If the core is an illusion, better data will reveal it. Until then, I'm watching the next star swing past Sagittarius A and asking, does the universe prefer one monster or many pretending to be one?